Hello, this is Dr. Hanaa Assil, and this is paper 1CR, January 2022 in the IGCSE Chemistry Edexcel. Let's take a look at the questions and discuss the answers. So the first question is about acids, alkalis, and indicators. Which of these is the color of litmus indicator in an acidic solution? Remember, what are the colors in the litmus? If I put it in acid or in base? He's asking for acid, so you should know that litmus paper in acid it is red, while in base it is blue. So that is answer C. Then which of these is the pH value of a neutral solution? Remember, if I have a neutral solution, that is pH what? That is pH 7. Which of these describes a solution with a pH value of 9? Again, remember, pH value of 9 would be what? The pH value of 9 would be a weakly alkaline solution. I'm going to remind you again, 7 is neutral. Anything below 7 is acidic. Anything above 7 is basic. A strong acid would have pH 1, 2, or 3. A weak acid would have 4, 5, or 6. A weak base has 8, 9, or 10. And anything 11 or above is a strong base. So remember these typical pHs. Then he says, which of these is the chemical formula of an acid? Well, remember that when we write the formula of an acid, we usually start with H. So hydrochloric acid is HCl, nitric is HNO3, sulfuric is H2SO4, and so on. So starting with H is an acid. Of course, H2O is not an acid, that is water. So that's not an acid. Otherwise, if it starts with H, it is probably an acid. Name the type of reaction that occurs when an acid reacts with an alkali. Again, when we react an acid with an alkali, that is called neutralization reaction. Acid plus base to give salt plus water. Name the two products of the reaction between hydrochloric acid and potassium hydroxide. Okay, hydrochloric acid plus potassium hydroxide should give a salt plus water. Now, which salt is it? Potassium chloride. So my products are potassium chloride and water. State the meaning of the term solute. Again, I'm going to remind you, please revise definitions. The easiest question you can have is what is meant by, or state the meaning of. So what is solute? You should remember, if I'm adding, for example, sugar to water or salt to water. Now, which one is the solute? The solute is the substance that dissolves in a solvent. So the one that is dissolved, which would be the salt, for example, or the sugar, that would be the solute. State the meaning of the term solvent. Of course, the solvent is the substance in which a solute dissolves. So that is the water, for example, that is the solvent. Explain what is meant by a saturated solution. You have to remember, a saturated solution is one that contains as much solid dissolved as possible at a certain temperature. Remember that at different temperatures, different amount of solids may be dissolved. So at a certain temperature, if I dissolve as much solid as possible, then I have made a saturated solution. I'm going to remind you again that the word saturated has two meanings in our syllabus. If we're talking about saturated solution, that is a solution that has as much solid dissolved in it as possible at a certain temperature. But in organic chemistry, when we do the chapter on organic chemistry, we said saturated compound is one that does not have C double bond C. So the one that has C double bond C, which was alkenes, we called it unsaturated. The one that is not an alkene, no C double bond C, we say it is saturated. But here he's talking about saturated solution, so it has to do with how much solid I can dissolve in water. Again, when we do crystallization and we say heat to point of crystallization, we're actually trying to make a saturated solution. So what comes out when I heat to point of crystallization is a solution in which I have evaporated as much water as possible, so I have as much salt dissolved as possible. So that is my saturated solution. Then he says a dark purple liquid is diluted by adding water. The diluted liquid becomes a pale purple color. Explain the process that causes this change. So he's referring to something like this where we have a purple color and then we add water. So what will happen to the particles? Well, you should know that particles will spread out, move from area of high concentration to area of low concentration by the process of diffusion. This question is about chromatography. Two students carry out separate chromatography experiments to find the RF values of 5 different food dyes. State 2 things that should be the same in both experiments so that the students can compare their results fairly. So they're trying to compare the RF values of these dyes. So what should be the same in both experiments? Well, at least they should have the same solvent. They should be using the same solvent because substances will have different RF values in different solvents. They should also have same distance traveled by the solvent, or we could say the same type of chromatography paper. After doing the experiments, the students calculate the RF value for each food dye. State what can be concluded about dye C. Well, let's look at dye C. Where is dye C? In dye C, the RF value for both students is 0. When the RF value is 0, what does that tell you? It means that the spot remained on the baseline, and that means that the dye is insoluble in the solvent. Explain which RF value cannot be correct. Which one of these cannot be correct? Well, you should know that RF value should be numbers less than 1. You can't have a number for RF value that is more than 1. So dye D, student 2, which got 1.2 for his RF value, that obviously is wrong. The RF value cannot be more than 1. So here he's saying calculate the RF value of this food dye. So how do we calculate the RF value of a spot? Well, you should remember that the RF value is the distance traveled by the spot over the distance traveled by the solvent. Well, where is the spot? The distance traveled by the spot, that is the distance from the starting line or the baseline to the spot, divided by the distance traveled by the solvent, that is starting again from the baseline to the solvent front. Of course, the distance traveled by the spot is always less than the distance traveled by the solvent. That is why we said that the RF value cannot be more than 1. It has to be less than 1 because the distance traveled by the spot is smaller than the distance traveled by the solvent. Now, if we calculate this, he gives me numbers on the chart. So the distance traveled by the spot is 9.7. The distance traveled by the solvent is the 9.7 plus the 2.3 because I have to go up to the solvent front. So the answer for this is 0.808. But this is not my answer because he said give your answer to 2 significant figures. 2 significant figures means I should round up this number so that it will become 0.81. Remember that this, by rounding up, it has to be 0.81, not 0.80. So that is my answer. The next question says, state the meaning of the term atomic number. Again, what do we mean by atomic number? You should know. Atomic number is the number of protons in the nucleus. The atomic number is the number of protons, and that is in the nucleus. An atom of element X contains this number of protons, this number of electrons, and this number of neutrons. Which of these is the mass number of this atom? How do we get mass number? The mass number, you should know, is protons plus neutrons. So 14 for the protons plus 15 neutrons. That will give me a mass number of 29. Explain which group of the periodic table element X belongs to. Well, he told me that element X has how many electrons? 14. You should know that to distribute the 14 electrons, they should be 2, 8, 4. And that means that this element has 4 electrons in its outermost shell, and that means it is in group 4. When he says explain, make sure you explain. Don't just say group 4. Why is it group 4? Because it has 4 electrons in the outer shell. Remember that the number of electrons in the outer shell is always the same as the number of the group. The table shows the composition of a sample of a different element Y containing 3 isotopes. Using the information from the table, calculate the relative atomic mass of this sample of element Y. Again, when he gives me the mass number and the percentage of each one, how do I calculate the relative atomic mass? You should remember, it is the mass number of one times its abundance, or its percentage, plus the mass number of the other times its percentage, plus the mass number of the third one times its percentage, and the total percentages here is out of 100, so I divide by 100. This gives me a number, 32.0925. But that's not my answer. Always pay attention to what he says. Give your answer to 1 decimal place. Again, you need to round up. So this to 1 decimal place is 32.1, not 32.0. You should all know how to round up a number. Okay? Then this is a question about metals and their compounds, and he's saying state one property of metals. Now, what is common to all metals? You should remember that all metals are good conductors of electricity. You can also say that they are malleable or ductile or shiny. These are all properties of all metals. Then he says mercury is the only metal that is liquid at room temperature. Describe the difference in movement of particles in liquid mercury and in a solid metal. Of course, you should know how particles move in each of these. In liquids, particles move around each other, or we say they slide over each other. In solids, particles vibrate in fixed position. Magnesium is a metal that burns in air. State one observation made during the combustion of magnesium metal. You should remember when magnesium burns, remember we said it will burn with a white flame or a bright flame. So magnesium, he's saying during the burning, during the combustion, the magnesium will burn with a white flame. And then state one chemical property of the product of combustion that can be used to classify magnesium as a metal. When magnesium burns in oxygen, of course, it gives magnesium oxide. And by the way, if I'm asked what is the appearance of magnesium oxide, you should know that it is a white solid or a white ash. Now, what about this solid can be used to classify magnesium as a metal? Well, let's see. Is magnesium oxide acidic or basic? You should know that magnesium oxide is basic. Now, this is oxide that is basic, and that means that magnesium is a metal because oxides of metals are usually basic. In the absence of air, magnesium reacts with sulfur to form ionic compound magnesium sulfide. Give a reason why the reaction needs to be done in the absence of air. Of course, if I do a reaction in air, then the metal reacts with oxygen. So I want it to react with sulfur, not with oxygen. So I have to do it in absence of air, or magnesium would react with oxygen instead of sulfur. Describe in terms of electrons the formation of the ions in magnesium sulfide and give the charges on the ions. Now, When magnesium reacts with sulfur to form magnesium sulfide, what is happening? You should realize that magnesium is in group 2. It has 2 electrons in its outermost shell, so it wants to lose these 2 electrons. Now, sulfur is in group 6. It has 6 electrons in its outermost shell, so it needs to gain 2. So what happens is the magnesium atoms will lose 2 electrons, and that means it will become magnesium 2 plus or Mg2 plus. Now the sulfur atoms will gain 2 electrons and will become S2 minus. Explain why magnesium sulfide has a very high melting point. Again, magnesium sulfide is what? It's ionic. Why does it have high melting point? Due to strong attraction forces between what? Positive and negative ions that need a lot of energy to be broken. This is how we explain why any ionic compound has a very high melting point. Magnesium sulfide reacts with hydrochloric acid to form magnesium chloride and hydrogen sulfide. Give the chemical equation for this reaction. So of course we're going to write the equation, and please pay attention that valency of magnesium is 2. So magnesium chloride has to be written MgCl2, and that means I will need 2 in front of the HCl to balance. Please do not leave any equation without balance. Ocimene is an organic compound that gives some plants their particular smell. The molecular formula of ocimene is C10H16. Calculate the relative formula mass of ocimene. How do we calculate relative formula mass? It is the mass number of each one times how many we have. So the mass number of carbon is 12 times 10 plus the mass number of hydrogen is 1, and I have 16 of it. So the total MR is 136. Then, using ocimene as an example, explain what is meant by the term empirical formula. Again, if you're not familiar with definitions, please revise definitions before going to the exam. What is meant by empirical formula? You should know that empirical formula is the formula showing the simplest ratio between the atoms. So if I tell you that the molecular formula of ocimene is C10H16, what would be its empirical formula? You should be able to simplify 10 and 16. Well, divide by 2, then the empirical formula is C5H8. So that is the simplest ratio between the atoms. The displayed formula of ocimene is this. Explain why ocimene is described as an unsaturated hydrocarbon. So you have to tell me, why do we say it's unsaturated and why do we say it's a hydrocarbon? It's unsaturated because it has double bonds. So unsaturated because it has carbon-carbon double bonds. Why do we say it's a hydrocarbon? Because it is made up of carbon and hydrogen atoms only. Then ocimene is an alkene. Which of these types of reaction occurs between an alkene and bromine? Remember, if I have an alkene, it reacts with bromine, the double bond opens up and I put a bromine atom on each carbon. This is called addition reaction. When we react alkenes with anything, it usually does addition reaction. If we react alkenes with halogens, that is what we call substitution reaction. Of course, precipitation reaction is any reaction that forms a precipitate. And polymerization, you should know, is the one where we start with many, many small molecules, join them together to form a large molecule. Many alkenes have the general formula CnH2n. Now suggest why ocimene does not have this general formula. So let us look at ocimene. What is the difference between ocimene and the other alkenes that we studied? It has more than one double bond, so this general formula of CnH2n does not apply to it. Ocimene can take part in combustion reactions. Complete the equation for complete combustion. Remember, complete combustion of any alkane would give carbon dioxide plus water. And then you need to balance. So we have 10 carbons, we need 10 carbons, we have 16 hydrogens, we need 2 times 8, and to balance the oxygens, we will need 2 times 40. Two different products can form during incomplete. So remember, complete gives carbon dioxide and water. Now, incomplete, he's telling me it will give one product, which is a solid, and the other is a poisonous gas. Remember, incomplete combustion can give you what? It can give carbon or the black stuff, which we call soot, and a poisonous gas, which is carbon monoxide. Now, why do we say that carbon monoxide is poisonous? Remember, this is because it reduces the capacity of blood to carry oxygen. So it attaches to the red blood cells, so less red blood cells are carrying oxygen around the body. So we say it reduces the capacity of blood to carry oxygen. Explain the meaning of thermal decomposition. Remember, thermal means heat. Decomposition means breaking up. So you should know that thermal decomposition means the breakdown of a compound. Of course, in order to break down, it has to be a compound. You cannot break down an element, for example. So breakdown of a compound using heat. So it has to be using heat in order to be thermal decomposition. Then he says the equation for thermal decomposition of potassium hydrogen carbonate is this. Calculate the maximum mass of potassium carbonate that could be produced from the thermal decomposition of 2.5 grams of KHCO3. So he's starting with 2.5 grams of potassium hydrogen carbonate, and he's asking how much mass of potassium carbonate should I get? Well, the 2.5 grams of potassium hydrogen carbonate I can use to get number of moles, but I will need to calculate the molecular mass of the KHCO3 first, and then I can get the number of moles is mass over molecular mass. So the mass over the molecular mass gives me the number of moles of KHCO3. Then he's asking about what? Potassium carbonate. Well, look at the equation. You'll find that the potassium carbonate is half potassium hydrogen carbonate. If I have 2 of KHCO3, it will give me 1 of K2CO3. So the number of moles of the K2CO3 is half of that. And that means I can use that to get the mass by calculating the MR. And the mass is number of moles times the MR. So that means that I will end up with 1.725 grams of potassium carbonate. A student uses this apparatus in an experiment to study the rate of reaction between zinc and dilute sulfuric acid. This is the student's method. Add a few zinc granules to a conical flask on a balance. Add 100 centimeter cubed of dilute sulfuric acid to the flask. Start a timer and immediately record the mass. So he is measuring the mass every minute until the mass remains constant. The mass of the flask and contents decreases because hydrogen gas is produced. Of course, this is metal plus acid, so it gives hydrogen gas. The student uses the mass readings to calculate the total mass of hydrogen produced. So, first of all, he's saying complete the equation by adding state symbols. Zinc, you should know, zinc is a metal. All metals are solids, of course, except mercury. Sulfuric acid, all acids are aqueous. Zinc sulfate, please realize this is also aqueous. And hydrogen, of course, is a gas. Then he gives me a table to show the student's results. And he's saying, plot the student's results. Plotting means I use small x's or dots with circle. Please do not plot a graph using only dots. Draw a circle around the anomalous result. What do you mean by anomalous result? It's the one that's away from the curve. So obviously this one is away from the curve, and then I can draw a curve of best fit through the points. Give a possible reason for the anomalous result. Remember, the anomalous result is below the graph, and that means that he probably took the reading too soon. he was supposed to take a reading at certain time intervals. If he did not wait for the time that he's supposed to take the reading, then he took the reading too soon, then that is probably why he got the anomalous result. Determine a more likely value of this result that you get from the graph. So at that point, we circled the one at 6 minutes. So at 6 minutes on my graph, he was supposed to have 172 milligrams. Explain how the shape of the curve shows how the rate of the reaction changes as time increases. So first of all, I have to tell him how the rate changes and explain how the shape of the curve shows that. So first of all, as I look at the graph, I will see that the rate decreases with time. And this is because the slope becomes less steep. Remember, the curve is bending downwards. So we say that the slope is less steep. If it was going straight up, 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 then we say that it is getting steeper, then the rate increases. But here, if this slope becomes less steep, then this means that the rate decreases. At the end of the experiment, there is no zinc left in the flask. Give a conclusion the student could make from this observation. So I have zinc and HCl. If I say that at the end there is no zinc, what does that tell you? It tells you that the other one was excess. So all the zinc has been used up. That means that the acid was excess, or that the zinc is a limiting reagent. Remember, the one that is not excess is limiting. You know what excess means. The acid was excess, that means I used too much acid. So the zinc was all used up and the reaction stopped. So that means that the acid was excess. The student does another experiment using the same amount of similarly sized magnesium granules instead of zinc. So now he's going to repeat the experiment using magnesium instead of zinc. And he's going to use the same volume of sulfuric acid but lower concentration. Now explain, and he's doing this at the same time in the same experiment. So explain why it is difficult to predict how the rate of the reaction in this experiment compares with the rate of the reaction in the first experiment. So when he does this using magnesium instead of zinc and acid of lower concentration, will his experiment be faster or slower? That is very difficult to determine. Why? If I use magnesium instead of zinc, which one is more reactive? You should know that magnesium is more reactive. So if I use magnesium instead of zinc, my reaction should be faster. But then, at the same time, he's using acid of lower concentration. You should know that lower concentration means the rate should be slower or less rapid. That means that one of them is going to make it faster, the other one is going to make it slower. So it would be difficult to determine which change has greater effect. So I cannot tell overall, would my reaction be faster or slow? Do we understand this? Okay. Explain in terms of particle collision theory how increasing the temperature affects the rate of a reaction. We said, first of all, you have to tell me how, and then you have to explain. Some students forget to say how, they just explain. He didn't say that it will make it faster or slower. You have to say, if I increase the temperature, it will make the reaction what? You should know that if I increase the temperature, the rate increases. Now, explain why particles gain more kinetic energy, move faster, more frequent collisions or more collisions per minute, and more particles have energy higher than activation energy. Okay? A student is given a mixture of two white solid compounds and a colorless solution containing the same two compounds. The student is told that one of the compounds is a halide and that the other compound is a carbonate. Give two reasons why the student should know without doing any tests that one of the compounds cannot be copper carbonate. Why is it that one of my solids cannot be copper carbonate? Well, you should know. First of all, he said up there that they are white solids. Is copper carbonate white? No, copper carbonate is green. And then he says they form colorless solution. That means it dissolves in water. Well, copper carbonate cannot dissolve in water. It is insoluble in water, so it cannot form a solution. So copper carbonate is green, not white, and it is insoluble in water, so it cannot form a solution. Describe tests the student could do to show that the mixture contains potassium carbonate and potassium iodide. And these are 6 marks. Remember, you're supposed to describe tests for what? Tests to show that we have potassium, and tests that we show to show that we have carbonate, and tests for iodide. So potassium, carbonate, and iodide. What is the test that we have for potassium? You should remember it is flame test. Please remember the colors of the flame tests: lithium, red, sodium, yellow. Potassium is what? Potassium is lilac, calcium is brick red, and copper is blue-green. So to test for potassium, do the flame test. Potassium should give lilac flame. So that's the test for potassium. Then I want the test for carbonate. Well, what was the test for carbonate? A dilute acid. Actually, it should be any acid, but usually we specify dilute HCl, but it could be any acid. Carbonate gives bubbles of gas that turn lime water milky. Remember, identify you're doing test for what. Don't just say add HCl, it gives bubbles of gas. That is test for what? Test for carbonate. And then we're left for iodide. What is the test for iodide? Remember, we have a test for chloride bromide iodide. We said add dilute nitric acid and silver nitrate. The iodide should give a yellow precipitate. A student is given a pure sample of sodium carbonate crystals and is told that the formula of the crystals is this. State what X water in the formula shows about the sodium carbonate crystals. When we have sodium carbonate, something water, X water, 5 water, whatever. What does that mean? You should know that that means that the crystals are hydrated. It's a hydrated salt, or that it has water of crystallization. The student uses this apparatus to find the value of X. So the student's method, he said, find the mass of an empty crucible without a lid, add some sodium carbonate crystals to the crucible, find the total mass of the crucible and sodium carbonate crystals, heat the crucible to remove water from the crystals, allow the crucible and contents to cool down, find the mass of the cold crucible and contents. So he gives me the results, the empty crucible alone, the crucible and the hydrated salt all together, that means the salt with its water, and the cold crucible and contents, that is the crucible after I have finished heating, that means it is the sodium carbonate without the water. Okay, then he says calculate the mass of sodium carbonate left after heating and cooling. So the mass of sodium carbonate without the water. That would be which one? That would be the crucible and contents after heating. So that's the 25.93 minus the empty crucible alone. So that will give me the sodium carbonate without the water. Then he's saying calculate the mass of water. How do I get the mass of water? Well, the mass of water is the mass of the crucible and the hydrated salt, which is 29.71. minus the crucible and the contents at the end, that is the solid without the water, so that I can tell how much water has been removed. And then he says, show that the student's results suggest that the formula of sodium carbonate crystals is sodium carbonate 7 water. That means he's trying to get X. And we said to get X, we do it as if we're doing empirical formula. Sodium carbonate, we said alone, it is 3.18. The water alone is 3.78. And then we do it as if we're calculating empirical formula. So the first thing we do is divide by the MR of each one. So I get these numbers. And then I divide by the smallest. And that comes out to be 1 to 7. The student's teacher says that the correct formula of the sodium carbonate crystals is actually 10 watt. The student did not make any mistakes in their measurements. Explain what could have caused the student's value for X to be too low. Remember that I am supposed to heat to get rid of all the water in order to be able to calculate the amount of water. So probably what happened is the solid was not heated long enough, so not all the water was removed. And this is because what we should have done, or what the student should have done, is we usually reheat, cool, reweigh, and keep doing that until we reach constant mass. What he did was just heating once and weighing it, and that's it. Well, how does he know that all the water has been removed? We need to repeat the process, reheat, allow it to cool, reweigh, and so on until the mass is constant. A student investigates the temperature change during the reaction between zinc metal and copper sulfate solution. The student considers two different methods. So the first method, he used polystyrene cup. He put 50 centimeter cubed of copper sulfate into a polystyrene cup, recorded the temperature, added zinc powder, and stirred using the thermometer and recorded the highest temperature. In the second method, he did not use polystyrene cup, he used a glass bottle, but he closed it with a bung. So record the temperature of the copper sulfate, pour the copper sulfate into a glass bottle, add the zinc powder, push the bung and thermometer into the bottle and record the highest temperature. So notice that here he's not stirring the solution. So he's saying discuss the advantages and disadvantages of each method. And this question is 6 marks. So please try to think of any possible answers so that you can get as many marks as possible. So let us take a look at method 1. What did he say in method 1? He said he was using a polystyrene cup. That's good. So that's an advantage. And he was using polystyrene cup. This is good because it's an insulator, so less loss of heat to the surroundings. And he was stirring it, so that is good. We should stir to ensure that heat is evenly distributed. So these are the advantages. What are the disadvantages? Well, he did not use a lid. That's bad. He should have used the lid. No lid, so some heat will be lost. And the polystyrene cup, if you have ever used the polystyrene cup for any experiment, you would realize that it is a very light cup and it can tip over very easily and you can spill the solution very easily. So that is a disadvantage. You should pay attention that when we use a polystyrene cup, we usually put it inside a beaker to support it. So if he says in an experiment that he put it inside a beaker, why is he putting it inside a beaker? To support it so that it doesn't tip over. What about method 2? Well, method 2, the advantages was that he closed it with a bung, so that's good. It will not spill out and there will be less loss of heat. But the disadvantage was he was using a glass bottle, and that allows loss of heat to the environment, and he did not stir the solution, so the heat is not distributed evenly. The equation for the reaction is this. 50 centimeter cubed of copper sulfate solution contains this number of moles of copper sulfate. A mass of 3 grams of zinc is used. Show that the zinc is in excess. Showing that the zinc is in excess means I need to calculate the number of moles of zinc and then relate it to the number of moles of copper sulfate and see if it is the correct amount needed or more or less. So how do we get number of moles of zinc? Mass over molecular mass. He gives me the molecular mass. So that is 0.046 mole. Now I look at the equation and the equation says the number of moles of zinc should be the same as the number of moles of copper sulfate. Now he had 0.025 mole of copper sulfate, so actually what he needed of zinc is the same number of moles, but he put 0.04, which is much more, so this is more than the 0.025 mole that is needed, and that means that zinc is excess. The student reacts a solution containing 0.025 mole of copper sulfate with an excess of zinc. These are the students' results. Show that the energy change Q for this reaction is this. So he wants me to calculate Q. How do we calculate Q? Q is mc delta T. What is m? Remember that m is the mass of the solution, and remember that the volume of a solution is the same as its mass, because solutions have density of 1, or water actually has a density of 1, and we are assuming that the solution has the same density. So the 1 centimeter cubed of solution would be 1 gram mass. So 50 centimeter cubed of copper sulfate solution would have a mass of 50 grams, times the C, and he gives me C is 4.2, times the difference in temperature. He said he started with 21.1 degrees Celsius and he ended up with 40.6. So the difference, you calculate, this comes out in joules. So the Q comes out in joules. Usually we will need it in kilojoules, so we need to divide by 1,000. So it comes out to be 4.095 kilojoules. Then he says calculate delta H. You should know delta H is Q over N. Now what is Q? It is what we just got, 4.095. What is N? Well, he wrote it up there. It's 0.025. Remember, delta H must have a sign. Now, why did I decide that it's negative? Because I looked at the temperatures and I found that the temperature went from 21.1 to 40.6. That means the temperature went up. When a temperature rises, that means that the reaction gave out heat. That means it is an exothermic reaction, and that means delta H has to be negative. So remember, if the temperature goes up, delta H is negative. If the temperature goes down, delta H is positive, and you have to put the positive. You have to show him the sign. Okay? Then the last question says the ionic equation for the reaction is this. Explain what is oxidized and what is reduced. So let us take a look. First of all, what is oxidized and what is reduced has to be from before the arrow. Don't bring it from after the arrow. What is before the arrow that has been oxidized and what has been reduced? Well, you should realize zinc changed to zinc 2+. So it did what? It lost electrons. So zinc loses electrons, it is oxidized. Copper 2+ gains electrons and is reduced. And that's the end of the paper. I hope that this was helpful. Please revise any topics that you were not able to answer.